We have 7 questions in total. 5 are multiple select questions in which more than one option can be correct, and 2 questions are true false type. Total time allotted is 3 minutes. Let's begin. Time is up. Now we come to the answers. The longest wavelength at which photoelectric effect can be performed in a semiconductor crystal is also called as wavelength threshold and cutoff wavelength. These are just different names but represents the same wavelength. Select the false statements. In a semiconductor, a hole has positive charge equal to proton, which is true. But we have to select the false statements, therefore we will not select it. The unit of density of states Gc and effective density of states Nc are different. This is also true. The density of states Gc is defined as the density of states per unit energy per unit volume. However, effective density of states Nc is defined by density of states per unit volume. So the units for these two parameters will be different. Third option, doping intrinsic semiconductor with arsenic produces a semiconductor with huge population of free electrons and no holes. Because of the last two words only, this statement is false. It is true that a huge population of free electrons will exist, but there will be few holes as well. So, this statement will be false. Flow of electrons when a semiconductor is connected to an external battery is considered interband movement, whereas movement of electrons in different energy bands due to rise in temperature is considered intraband movement. This is also false. The definitions of interband movement and intraband movement has been interchanged. The formula for effective density of states Nc is, as you already know, that Nc is the effective density of states in the conduction band. So the right answer will be D option. For N-type semiconductor, select the correct statements. In earlier lecture, we actually have drawn the Fermi level diagram of N-type semiconductor at different temperature, which looks like this. This black line is representing the Fermi level of N-type semiconductor. Now, first option, EF lies below ED at room temperature. This is true. EF lies above ED at 0 Kelvin. This is also true. EF is equal to ED at some intermediate temperature. This is also true. EF is variant with temperature. Obviously, you can see that as we increase the temperature, then the position of the Fermi energy level EF also changes. Therefore, this is also true. For the p-type semiconductor also, we have drawn the Fermi level diagram which looks like this. Dotted line is representing intrinsic Fermi energy level, whereas this solid black line is representing the Fermi energy level of p-type semiconductor. The first important thing that you have to select the incorrect options. The first option we have is EF lies below EA at room temperature. From the diagram, we can say that this statement is false. EF lies below EA at 0 Kelvin. EF is here 0 Kelvin. It is lying between EA. Therefore, this statement is correct. So we will not select it. EF is equal to EA at some intermediate temperature. This is also true. EF is invariant with temperature. This is a false statement. Now we have two statements and we have to tell whether these statements are false or true. Intrinsic Fermi energy level EFI is at the middle of the conduction band and valence band at all temperatures. This is false. We have the expression so we can see that only at 0 Kelvin we have intrinsic Fermi energy level to be at the middle of the valence band and conduction band, which cannot be said true for any other temperature other than 0 Kelvin. The electron concentration N is the integral of Fermi energy level into effective density of states Nc with respect to energy E. This statement is also false. N is equal to integral of Fermi energy level multiplied by GCE, not Nc. Gc is the density of states, whereas Nc is the effective density of states at the conduction band only. You should read books for making your theoretical basics strong.